Okay, this is Chapter 1, Lesson 1, Evaluating Numerical Expressions. We're going to jump right in and see how this works out. Evaluating numerical expressions. We're kind of talking about algebra. An expression, a numerical expression, is just numbers. The book uses an example, 15 plus 9 times 3. And you have to know the order of operations to solve this. You have to know that you can't add 15 to 9 until you've multiplied 9 times 3. This is what has to be done first. So you leave the 15, and 9 times 3 is 27. And you add these two. 15 plus 27 is 42. We can see that if we write down 27 plus 15. 5 plus 7 is 12, and 2 plus 1 plus the carryover is 4, 42. Okay, see how that works? An algebraic expression with algebra includes a letter or a variable. Algebraic expression, the example they give is 45 divided by P minus Q. Okay, we can't do much about that unless we know what P and Q are, or unless we have an equation. This is just an expression. There's no equal sign. We start adding equations. Something that we can work with. They give you an example. Let's change colors. They say K plus 10, K plus 10. We don't know what that is, but then they tell us what K is. They say K is equal to 25. So we have an expression. We know what K is equal to, and they rewrite it like an equation. So K plus 10 is the same as 25 plus 10. So we have an expression. There's 10 on both sides. What would we get here? Substitute 25 for K. 25. It used to be K, now it's 25 plus 10, and that equals 35. Alright. They use multiplication for times n. And I want you to know you can use a dot. When you have a letter and a number, you don't have to use the dot, but you have to put the number first. This is appropriate for algebra, but n times 4 never looks like this. You never see any algebra teachers or mathematicians writing it that way. It's the number and then the letter. You have 4 of something. We don't have n 4s. We have 4 of something. It's the same thing. If you want to write it that way, use the dot. The dot is possible. You can also use a parenthesis. You've seen that before too. These both mean 4 times n. And the reason we don't use the x is because it looks like a variable. When we start using algebra, we can't use that. That looks like 4xn, and that is something completely different. So we have to use the algebraic numbering, the algebraic multiplication. 4 dot n, which means 4 times n, or 4n, or 4 parenthesis n. Now this works just fine, but if we have two numbers like 3 times 5, if we put those together without a dot or a parenthesis, it looks like 35, and that's not okay. It's 3 times 5, or 3 parenthesis 5. This is why it's important, because it's confusing and it needs to be clear. You can't write 3 times 5 without the dot or the parenthesis. But when you have a number and a letter, you can write them without, because it's clear. It doesn't look like 40n, because that's not a number. It's just 4n. Okay, I think that is probably sufficient for you to understand. If we have two variables, say a divided by b, but they tell you what they both are. A is equal to 8, and b is equal to 2. You can rewrite that. A is 8 divided by b, and b is 2, and 8 divided by 2 is 4. Works out pretty well. You can try some on your own down below. We're going to keep moving along. These are just in case you get stuck. Have to do something with two operations. Two operations means if they multiply and they add or subtract, or you adding or you have powers. They give you one with power. They say z. A lot of times I write a z like that with a little line here so that I don't get confused between a 2 and a z. Sometimes if you write them too quickly, it's confusing. I like to write my z with a little cross there just when I'm doing math. I don't usually do it anywhere else. Z to the second power, or z squared, plus 8.5 equals something. Well, we don't know what z is. And over here on the side, they tell you that z is equal to 2. So you have to rewrite that. Z squared is 2 squared plus 8.5. We have z plus 8.5 and 2 squared plus 8 plus 5. 8.5. Okay, 2 to the second power, 2 squared is 4 plus 8.5. So our answer is 12.5. 4 plus 8 is 12. 4 plus 8.5 is 12.5. So that's two operations. We just have to remember what to do first. Even if they had 8.5 plus z squared, and we knew that this was 2, we put it back in, 8.5 plus 2 squared. We can't add this and get like 10.5 and then square it. We have to remember that in order of operations, you do the powers before you do multiplying, before you do adding and subtracting. Remember, it's grouping symbols, then it's multiply and divide from left to right. Ha! Look at that, I forgot the powers. Grouping symbols, then powers. Ooh. Can't I do that a little better? Oh, I have an idea. You guys will like this anyway, so we might as well do it. Grouping symbols can move up here. Come back to the crayon. Powers. And then add and subtract from left to right. Okay, grouping symbols first, powers second, multiply and divide that direction, which is left to right, add and subtract from left to right. Okay, good job. Look through one more, maybe a couple more. They give you some functions. I like functions. We should look at the functions. They ask you to make a table. A function is like an input and an output. I like to think of a little machine. Machine, you put something into the machine and something comes out the other end, and it falls out. Say we put in times 2. So what happens if I put a number in the machine? Say I put 3 in. What comes out? 6, because 3 times 2 is 6. What happens if I put 4 in? What comes out? 8. What happens if I put 12 in? 24 comes out. And a lot of times they make a little chart. They'll give you a little chart and ask you to do this with a ruler so that it looks nice on your paper. And they'll say that the rule is, let's see, we'll go like this, and we'll make a little chart. It's like a function machine, but without the little picture of the machine. Okay. Get my pencil here, change colors back to, let's try green. Alright, so this is x, and the function is, say, we're going to add 3. And say we just put some numbers here, 2, 3, 4, and 5. So when 2 is x, it goes into the machine and comes out by adding 3. When you add 3 to 2, you get 5. It's like the machine that says add 5. Add 3. So this time it's the machine that says add 3. And you put something in, and something comes out the other end. And it's like a little slide. You put something in, and something else comes out. Put a 2 in, you add 3, and out comes a 5. Put a 3 in, out comes a 6, 4, out comes a 7, 5, out comes an 8. Notice we got 2, 3, 4, 5, 5, 6, 7, 8. These go together. This is what a function is. You put something in, something else comes out. We use this in algebra quite a bit. It's kind of a fun little game, but they'll have charts like this for you to fill out, and you see how that works. They also want you to be able to locate points in a coordinate plane. And I'll just kind of draw a real quick coordinate plane as a reminder. And we've got some little crosses here. This isn't going to be perfect, but it needs to be quick. Okay, say we use some numbers like this coordinate number 3, 2. The first one is an x, the second one is a y. And use the coordinate here. This is the x direction, and this is the y direction. X is always this way, y is always this way. The first one is always x, and the second one is always y. And this is kind of alphabetical order, x, y. You can kind of remember it that way. So 3, 2, you count over 1, 2, 3 in the x direction, and you count up 2 in the y direction. See, and you put your point right here. And this is the point 3, 2. Just like that. All right, if we had another point, 4, 1, that would be coming over 4 in the x direction. That means I'm going to have to change back to this because I only have 1, 2, 3. I'm going to add a 4 here. And sometimes you label them 1, 2, 3, 4, 1, 2, 3. So 4 over gets us to here. Try something with orange. We're going to mark this. 1 up gets us to here. And where did these two meet? You can almost draw an imaginary line through here, and an imaginary line through here, over 4, up 1, and where those two imaginary lines cross is where your point is. And this is supposed to be a parenthesis. 4, 1 is your point. 3, 2 is your other point. That's what it looks like on a graph. We didn't use these other areas, but we'll learn how to do that later. That's pretty much most of what you got going on here. I went really fast. If you need to, go back and watch something again. Made a couple mistakes. Hopefully you forgive me. It's how it would work if I was in the classroom teaching you too. I always make mistakes. A lot of times the kids catch me, and it helps straighten us out. This time I got to catch myself. I did it 1 or 2 times. I might have missed something else, but enjoy the video. Get your work done. We'll see you at school.